So you've got an Arduino board in your hands. You can feel the potential, right? This little thing can make stuff happen in the real world. But then you look at the code, and it's like, what is all this? Well, don't worry. Today we're going to pull back the curtain and break it all down. Let's decode the language of Arduino together.
I love this quote from a forum. It just nails it, doesn't it? It's that feeling of pure excitement mixed with the dawning realization that, yep, you're about to dive headfirst down a very deep and very, very fun rabbit hole. And that's really the first hurdle, isn't it? The possibilities seem endless, but then you open up the official documentation and, whoof, it's just a giant list of definitions. It kind of feels like someone handed you a dictionary and said, okay, now you can speak French. It's just not how we learn. But here's the secret, the thing they should tell you on page 1. Every single Arduino program, or sketch as they're called in the Arduino world, is built on the exact same super simple foundation. It all boils down to just 2 main parts.
The best way I've found to think about it is like a recipe. Every recipe has 2 distinct phases. First, there's the prep work. You get your ingredients out, you chop the vegetables, you preheat the oven. Then you have the actual cooking instructions, the steps you follow over and over. An Arduino sketch is exactly like that. Okay, so part 1 of our recipe is called setup function. See those curly braces? Anything you need to do for prep goes right in between them. This is a one and done deal. This code runs only a single time right when the board turns on. It's you telling the Arduino, hey, get ready. Here's the stuff we're going to need. And then you've got part 2, loop. This is the main event. This is where the magic happens. The code you put inside these curly braces, it doesn't just run once. It runs, finishes, and then immediately starts again from the top. Over and over and over, forever, as long as that little green light is on. That's the whole point. It's always running, always ready to react. So let's just recap real quick. Setup runs once. It's for all your prep and initialization. Loop repeats forever. It's for all the main actions, like reading a sensor or, blinking a light. Simple as that.
All right, so we've got the structure down, but it's an empty recipe. How do we actually make it do something? Well, for that, we need some action words. In programming, we call these commands or functions.
And this is the cool part. This is where the code you're typing on a computer screen reaches out and touches the real physical world. The commands we're about to learn are what control the electricity flowing through these little metal pins on the board. This is how software makes hardware come alive. First up, a command you'll use in almost every single setup section, pin mode. It's like giving each pin a job description. You have to tell it, hey, pin number 13, your job is to be an output. You're going to be sending signals out. Or maybe, hey, pin number 2, your job is to be an input. You're going to be listening for a button press.
So once a pin has its job as an output, you need a way to actually use it. That's where digital write comes in. It's super simple. You just tell it which pin, and then you tell it what to do. High, which basically means turn on, or low, which means turn off. And here's a great little pro tip. Most Arduinos have a tiny LED built right onto the board that's connected to pin 13. It's perfect for our first test. But hang on. If we tell the board to turn the light on and then immediately turn it off, our program's going to run so fast our eyes will never even see the blink. We need a way to tell it to just chill out for a second. And for that, we use the delay command. You just give it a number in milliseconds. So if you say delay 1000, you're telling it to pause and do nothing for 1 full second. So let's build the logic for our blink. It's a simple 4-step dance. Step 1, turn the LED on. That's digital write 13, high. Step 2, wait for a second. Delay 1000. Step 3, turn the LED off. Digital write 13, low. And step 4, wait another second. And because all of this goes inside our loop function, it's just going to repeat that sequence forever. Now, that code will totally work, but we can make it better. We can make it cleaner and easier to manage. To do that, we need to talk about one more crucial concept, variables. The easiest way to think of a variable is just as a labeled box, where you can store a piece of information. There are different types of boxes for different types of information, but the one we'll use most is the int, which is just short for integer. An int is a box designed specifically to hold a whole number. For something like a pin number, it's perfect. Okay, look at our code again. See how we've typed the number 13 in a couple of different spots? Programmers call that hard coding. Now, what if you decide later on to move your LED to a different pin, like pin 12? Well, you'd have to go hunt down every single 13 and change it. In a tiny program, that's just a little annoying. In a big program, It's a recipe for bugs. But check this out. Here's a much smarter way. At the very top of our code, we create one of those int boxes. We name it lead pin, and we put the number 13 inside. Now, everywhere else in the code, instead of the number, we use our name, lead pin. The result? If we ever want to change the pin, we just have to change it in one single spot. It's cleaner, it's easier to read, and it's way easier to maintain. Okay, the moment of truth has arrived. We've got our recipe structure, the setup and loop. We have our action words, our commands, and we have our handy little variable to keep things tidy. We have all the ingredients. So let's put it all together and build our complete Blink sketch. And here it is, the classic Blink sketch in all its glory. See how it all fits? Right at the top, we define our lead pin variable. Then, in setup, our one-time prep work, we set that pin's mode to output. And finally, in the loop that runs forever, we have our 4-step dance. Turn the LED on. Wait. Turn it off. Wait. That's it. It's clean, it makes sense, and it works. And just like that, you've done it. And here's the important thing. You didn't just learn how to blink an LED. You've actually learned the fundamental grammar of the Arduino language. Setup, loop, commands, and variables. I promise you, these are the core building blocks you will use in almost every single project you ever make.
What you really did today was learn a language, not a human language, but a language for talking to the physical world through this little computer. You now know how to make things light up, move, and respond. So the only question left is, what are you going to build next?